Okay, so we didn't go over the second page. You were supposed to look at these on your own. Kevin, what fraction did you pick for this one, where the exponent was between 0 and 1?
X to the 1/3.
X to the 1/3. Great. That looks like this. Tim, what did you pick for this one? An odd over even?
3/4.
And that looked kind of like that, right? There was no tail. Naomi, what'd you pick for this last one? And that one looked kind of like a seagull. Okay, so all of them look the same in quadrant 1, right? They're all concave up or down. Which one? Down. It's part of the frown. It's 1/2 of the frown. Then on the left, it either had a tail that went down, no tail at all, or a tail that went up. Okay, so I'm hoping that you guys don't actually just memorize this, but that you kind of understand. So the way to check, does it have a tail or not, I'm going to take -1 and plug it in. -1 to the 1/3. Do 3 things multiply to be -1? -1 itself, so it exists. So the coordinate -1 is on this graph, so it's going to go on through. Okay, here, -1 to the 3, and then to the 1/4. You guys said, okay, -1 times -1 times -1. 3 times, Joaquin, -1 times -1 times -1 is?
Wait, but where did the 1/4 come from?
This exponent, if I raise a power to a power, that multiplies, right?
Yeah.
So x to the 3 times x to the 1/4, 3 times 1/4 is 3/4. So on Friday, we worked with being able to pull the fractions, the exponents apart.
Okay.
Okay? So what's -1 times -1?
-1 times -1
Is +1.
Yeah.
And then times another -1
is
is -1. Okay, what times itself 4 times makes that -1 again? Spencer's got a confused look on his face because you can't. That's algebra 2, that gives you the I. So nothing times itself makes a negative, because a negative times negative makes a positive. So anytime this thing is even underneath, no tail. Can't do it. Doesn't exist. Yeah? Yeah? And then this one, Naomi said to the 2/7. So Joaquin, you okay if I pull it apart like that? So I'm going to do the x squared, and then I'm going to do the 1/7. Chloe, what's -1 squared? +1, yeah. And then 1 to the 1/7, it's also positive. So the coordinate -1 is on the function, so the tail's going to go up. That's how we test. Okay. All right, we're going to do the hard one. Boaz, what do you have as an exponent on this one? Odd over odd when it's less than 1. 1/3? Okay. All right. This guy is going to look like this. And testing a -1 in there, it's going to look like that. Allie, what do you have for this one? What was your fraction? -3/4. And just like the one above, that over 4 is a problem. I'm not going to have a tail. Nothing on the other side. Ella, would you pick as a fraction for the last one?
4/3.
Okay, to the negative 4/3. That's going to look like that. Okay, so the summary's on the back page, and hopefully we can generalize like what all these things are and what they do, so that you will do well tomorrow. We will try a few things. So if the exponent we put on that thing is bigger than 1, can you guys draw this in here? So this quadrant 1 sketch, if it's bigger than 1, it's going to look like that. And the other side, it depends on if it's a positive or negative. It might be a tail going up or a tail going down, or it might have no tail at all. But in that corner, it's going to look like that. Spencer, if it was a big old U shape, what's that equation that makes that just happy face?
Square.
Okay. You guys have been working with x squared since you were in algebra 1. Hopefully, you are comfortable with what y equals x squared looks like. Kinda, sorta, yeah? So, if the exponent is bigger than 1, it's gonna look like that smiley face, at least in quadrant 1. What's the concavity in quadrant 1? Up. Because it's part of that concave up business. So these are examples of the kinds of questions you're going to see on the exit card tomorrow. I'll pick some random number and say, x to the this, what's it going to be? Samara, the right end behavior, what is the right end behavior of this function? Goes to positive infinity, perfect. Jasper, this one, as we approach 0 from the right, where is this function going? It doesn't, it stops right here to 0. Lydia, does that make sense? Okay. Can you guys try the second one with your group, see what you come up with? What does it look like in that one quadrant alone? Someone just said it looks like square root.
It's not the same colors. They're different ones.
So, Amy, you've got answers for all of them? Okay, so write the 3 boxes down. A, B, and C. What did your group get? I agree with Gene Gideon. He said the function's going to look like a square root in that corner. So what's the concavity? What's the right end behavior? And what's the behavior as 0 goes from the left? We'll get that in there going that way. That one. So as we approach 0 from the right, where's the y line go? Questions? You're talking to the so that comes up. Oh, so you have you also have when the exponent is bigger than 1, it's going to look like x squared. This one
Wouldn't
is
it just be
square root.
like?
Hey, why?
We're on number 2. You didn't see number 1 with us that your name was gathered. I know what you're doing that.
If X is less than
Yeah, from the third one. So
less than 0.
0 is greater.
So I equals one.
I think you're right. No, I'm not sure. Again, I don't know.
So I'll show you. So concavity, up, down, which one? Concave down, do you guys agree?
Yeah.
Yeah.
So this is concave down, so it's this part of it? Yeah, concave down. Right end behavior, Ashley, what did we get for the right end behavior for the second one? Positive infinity. And Natalie, as we approach 0 from the right, we're coming at it this way. Where's that y value going? 0. Okay. The last one, the negatives. They're going to look like 1 over x. Which 1 over x looks like that. So in quadrant 1, it's going to do this. So these 3 answers are weird. Arden, any guess? What's the concavity in quadrant 1? Up. You're correct. Charles, what about this one?
I said 0.
0. Perfect. As we go to infinity, you have 1 pizza to share with everyone in the class. And then Charles goes and tells people down the hall, now we gotta share with all them, and they go tell everybody else in the school, and now we gotta share that pizza with the whole world. How much pizza is Charles getting because he opened his mouth? You get no pizza. Neither does anyone else. No pizza. Because we're sharing with everybody. Okay. Sorry. Always gotta pick somebody. 0 from the right. It's the weird answer. What is it?
Infinity.
Positive infinity. Okay. So, Alicia, pick a number. 3. Bailey, pick a number.
5.
All right, so tomorrow I might say, here's your function. Tell me all these things. Concavity in quadrant 1. Right end behavior. Maybe I will ask left end behavior just to be spicy. Maybe I will ask, what is the function as we approach 0 from the right? Is it even? Is it odd? Is it neither? Here's how you answer that question. First thing, that exponent, is it bigger than 1, between 0 and 1, or less than 1? Between? So it's between 0 and 1, so which function is it going to look like? Is it going to look like y equals x squared, y equals square root, or y equals 1 over x? It's going to look like square root. Why? Because 1/2 is between 0 and 1. So any number between 0 and 1 is going to look like this. All right. Now, next question. Does it have a tail or not? Does the tail go down or does the tail go up? How are we going to tell? Lucia, are you confused because you weren't here on Friday?
Yeah, a little bit, but
Okay.
kind of reviewing.
Okay. So, does it have a tail or not? If I put in -1, this is the thing we're going to test. -1 to the 3. Booking told us earlier, -1 times -1 times -1 is -1. So now I'm going to do -1 to the 1/5. Does something times itself 5 times equal -1?
-1.
Yes, -1 does. So it's going to have a tail. So there's my quick sketch. My sketch of the graph is this. So for myself, that's what I have now. So Lucia, what's the domain? Are there any x values I need to throw out of the function? No, so what's the domain?
All real numbers, negative infinity to infinity.
Yes.
Positive infinity.
What's the range? Fakir? What's the range? Are there any y values it's never going to hit, or is it going to be all of them? Oh, she's whispering. She doesn't want you all to know. So it's really slowly going up and really slowly going down, but it's getting there eventually. Dylan, what's the concavity in quadrant 1?
Down.
Down. Okay, Noah, right end behavior. So it goes super duper that way. Where's it going on?
Negative infinity? Oh, positive infinity?
Positive infinity. Beckham, as we go super duper negative infinity. It is also negative infinity. Nate, 0 from the right, where does it go?
0.
0. Okay. Is it even or is it odd or is it neither? Cameron, what do you think? Odd. Because we can spin it around here and see the same thing. Yeah. Okay. That could be one of the questions tomorrow. I'm going to change the problem now. You ready? I should pick a better color. Now it's negative 3/5. Negative 3/5. So Samara, is the exponent greater than 1, between 0 and 1, or less than 0? Less than 0. So this picture is totally wrong now. Come on, erase. Thank you. So now that it's less than 0, it's going to look like that. Velez, do you remember how we're going to test to see if it's got a tail? No? Holiday, how am I going to test to see if it has a tail?
If the denominator is even.
Okay, that's one way to do it. So the denominator is odd. Does it have a tail or not?
It does.
They say it does. And the way I check it is testing -1. Come on. -1 to the 3. Again, Joaquin says it's -1. God, how many times do I have to tell you? And then what times itself 5 times is 1, or sorry, -1 is -1. All right, here's the hard one though. Domain. Can I put everything in, Tim?
No.
What's the one thing I gotta kick out?
0.
Okay, the domain of this one, all of the numbers except 0. Naomi? Range. Can I get all of the y values? No. Which one do I gotta kick out? Is it ever gonna hit this?
0.
So the range is everybody but 0 also. Chloe, what's the concavity in quadrant 1? Up. Right end behavior. Tessa, right end behavior. As we go to super duper infinity that way.
You get closer to 0.
Closer to 0. Had my one pizza cut into a bajillion pieces because Charles invited all his friends and he's just too popular. Emmy, how about at negative infinity? As x goes super duper negative infinity, what's the y value going to? Where's the y value going? What's that height? 0. Jonathan, as we approach 0 from the right, what's going on with the function?
Infinity.
Positive infinity. Is it even, is it odd, is it neither? If you spin it upside down, do you see the same thing? I see the same thing, so it's odd. So that's two kinds. We need to do one other. Ally, pick a number. Two. Okay. Jasper, pick an odd number.
7.
So is the exponent now bigger than 1, between 0 and 1, or less than 1? Or less than 0? Bigger than 1. So it's going to look like that in quadrant 1. Is it going to have a tail or not? This side of the room's shaking their head no. Why is it not going to have a tail? Even denominator in that exponent is one way to do it. Can't square root a negative something. So that's my graph. Okay. Is the domain all reals? Sophia, what's the domain? What x values can go in?
0 to infinity.
Square bracket or round bracket on that 0?
Round.
Square. Includes 0. I can do the square root of 0. That's no problem. Spencer, what's the range?
Like 0 to infinity.
Also 0 to infinity. Right end behavior, what is it? Lucia, what do you think? What's the right end behavior? As x goes to super duper positive infinity, so x is going that way, what's the y value doing? Positive infinity. Left end behavior. There is no left end, because left end is the end of time. At negative infinity, it's not there. All right. Even, odd, neither. Why?
Can't flip it over and get the same thing.
Didn't have that side, so it's not even. Didn't have that down there, so it's not odd. It's a neither. Okay, yeah. All right. So, for you guys to try your own. Take one in the back. In, extras, can you hand them back for where they're going? Sorry, Spencer, what? Okay, I'll talk about that in a second. Did you guys get them? Did you guys have any extras, or that's it? No? Did everybody over there get one? Yeah.
Yeah, but
Pardon?
in the grade book is
And there was a question about the test. The tests are graded and the scores are in, and the test was out of 40 points, but scaled down to 30. As 40 points, we're not allowed to have any single assessment worth 25% of your grade, and 40 points was over that. So those of you who did very well, which is some of you did absurdly well, it only counted as 30 points, but yay, you did well. Woo. Okay. So it was scaled down, but it's still in there. So what you just got is a way to hopefully summarize your thoughts. Hopefully you can do it without the packet. So exponent 0 to 1, what's it look like? This, or this? So make your, like, fill out your little chart of stuff, like this is the thing to study from. And here's examples of each one down below, and sorry, this A isn't supposed to be there. So see if you can create a study sheet for yourself, and then answer the questions at the bottom. Okay, so all we did. Daughter has slumped the same as 3 reactions. So you. So X to the something, so like really, all you gotta think about is that something bigger than one between 3 or 4 hundred. And then hopefully, you know what X squared looks like, and you know what square root looks like. The hard one you guys are not comfortable with is this guy. So it's those 3 things, and then you just gotta look as there's gonna say denominator of the exponent. So it's even. If it's 5. The numerator's even. Why is that? Oh, it's part of my. Okay, I would like people to volunteer to put up their answers to these 3.
Man, you definitely was praying to God that
And if there's no volunteers, I have ways of picking names.
Your favorite race? Even. George Russell's pretty good.
He's getting more consistent.
I think that match was back for the
For, like,
Whole-
yeah.
All right,
There's a whole
so,
class like this.
someone just said, how do we know if there's a tail or not?
Yeah,
Um,
it should be. Oh, okay.
Lucia, how do we check if there's a tail? How do we check if the function is like this, this, or this?
You can see if the denominator is even, then there's no tail. And if it's odd, then there's a tail. So we have to like that.
So looking at the denominator of the exponent, she said if it's even, no tail. If it's an odd, tail goes down. How do we get the happy tail?
It's greater than
When
one.
what?
No fraction is greater than one.
If the numerator of the exponent is even. That's it. Bell didn't ring, so let's see. And I'm looking at the wrong class. All right, Jonathan, can you put up what you got as answers for the first one on the left? Left. All right, guys, see you tomorrow. Please bring your Chromebooks, make sure they're charged.